All right, so what we're talking about limits is looking at this picture, the graph below is given a graph, and that graph has almost like, there's a jump, right? There's a jump up from here to here. But when we talk about limits, we're saying specifically what would it look like? What should it look like? And we had a little marks here. If you can see that little negative here, that little negative means from the what? That means from the left side. I should rewrite this, from the left side. This here means from the right side. So what does the graph look like as x approaches from the left side of -1? We see -1 here. I'm going to draw a vertical line so you guys can all see it. That's -1. So what does the graph look like if I'm approaching from the left road? The graph looks like -2. That's all we're saying. What does the graph look like as we approach from the left side? That looks like -2. What about the right side? The graph approaches, and I'm on the right side. See, I'm on a totally different road here from the right side, and that looks like +2. What is the limit overall? Is there an answer from the left and the right? There is no consensus. One person says the elephant looks like a hose. The other person said the elephant looks like a tree. They are both wrong. There is no limit, does not exist. DNE. And last one, what is the actual value? This is not limit. This is. What is it? And at -1, let's take a look. I'm gonna use a ruler here. Take a look at -1. The actual graph, actual graph is going to be at right here. See this? That's -4. So the actual value here is going to be -4. You do not need work for this, and by you can use a graphing calculator for this. This is just being able to read the graph. Okay, so you'll have a couple of these questions on your review test. Okay. Let's look at question number 2. Very similar style. Right, and the number has moved over. Actually, no, this is actually slightly the same thing. And we're gonna ask the same exact question. So you can take a look at that when you guys practice the test. Hopefully you guys can get this answer also. Hopefully you've learned how to do limits. The same idea here. We are from a graphical approach. I see a graph. What does the graph look like as we approach the graph at 2? So just to show you guys, we're at 2. This is 2, right? That's the value we're trying to get to. But we're talking about different sides. We're talking about the left side, the right side. Now, why do we come up with like the plus and minus? It's because it makes our life easier, left and right. So we use a minus sign and a positive sign to make it easier on us, to save time. Math is all about saving time. Why do you think they came up with pi? Because they didn't want to keep writing 3.141592, right? Just write the symbol pi to save time. Now over here, so we're gonna go ahead and say, what is it from my left side? Approaching from my left side, coming down on my left side, it looks like it's gonna be -2. All right. From the right side here, on the right side, we're approaching 2 from the right side. That's going to be -2 also, right? That's a y value. And then from the left and right side, -2 and -2, they both agree, hey, the value actually looks like -2. But is that the actual value? The last question, what is it actually? What is it? It is actually 4. Okay. And these are some notations that we want to make sure we're good with. Again, because calculus and math, all about is trying to write something efficiently in a way that everyone can understand. We have a consensus here. Now, again, question number 4 is the exact same thing. Now, looking at limits as we go into infinity, I want you guys to look at this problem here. Enter the limit. If the limit is infinity, enter 0, 0. Now, please be aware, this is how they want you to enter it. And if you see this question on a test and you try to write infinity, it might not take it, okay? So enter 0, 0, and then enter -0, 0. And if no limit exists, they want you to write it as, let's see, what does this say? Oops. I can't see it, let me move it. Does not exist, DNE, okay? They want you to write DNE. Okay, so looking at this graph, what does the graph look like at what point? So as the function approaches, as the function gets closer to 2, but from the right side, what is the y value? Okay, so that's fine too. You guys can all visually see that this is 2. Now from the right side, as I'm approaching 2 from the right side, the y value, what happens to the y value? It gets bigger and bigger and bigger, right? So where do you think we're headed to? We're headed to infinity. So they want us to write 0, 0. What about from the left side? If I was approaching from the left side, if this was written as limit, as x approaches 2 from the left side of f of x, from the left side, this becomes negative infinity because the y value keeps getting lower and lower and lower. He's going to hell. Oops, don't want to save that one. Okay, and if I write 0, 0, let's look at the answer. Answer, you can write 0, 0 or infinity. Let's go ahead and write 0, 0, see if that works out for me. Apparently the infinity sign works also. Let's write 0, 0, see if that works. Is it 0, 0 or 0, 0? That's try. Actually, it might be 0, 0. Oh, it changes automatically. See that? 0, 0 changes to infinity. That's kind of cool. Submit. Okay, all right. To save time. Okay, same idea here. What does graph look like as we approach infinity? Now this question is, look at where x is going. X is going, read it, x is going to infinity. All right, so as x goes this way, what do you think happens to the y value? Is the y value shooting up to infinity? Is it going down to negative infinity? Is it swinging around all of a sudden? Nope. So as y goes to infinity, take a look at this graph. It's actually getting stuck. And what value is it getting stuck at? It's getting stuck at 2. Now that's a big deal. A lot of these questions that you have, they're going to be super easy questions because they're just asking you to look at the graph. Sure, but we're not really into the hard part of it yet. It's just what's a visual version of this limit. Now, once we finish the visual part, we're going to go ahead and actually do the algebraic. Oh gosh. All right, so let's go into our next problem. And now we're going to look at this from an algebra standpoint. We're not going to be given the graph. You could graph this, but it's going to take us so much more work to just graph it. Instead, let's just go ahead and ask ourselves, what are we trying to say here? The limit, fine. What does limit mean? It means what does it look like? So what does the graph look like as I approach 5 from the left-hand side? What happens when I approach 5 from the left-hand side? Now, which of these graphs, a piecewise function is a graph made up of different parts. And I made a joke about this before, that the person you are before school and the person you are after school are two different people. You act differently at school as you do at home. And this graph acts differently before 5 as it does after 5. X is greater than 5, so we're going to be the bottom equation. And if we're less than 5, we're on the top equation. Now, what numbers are looking at a number line? If I say this is 5 here, what numbers are less than 5? Is that 4, 3, 2, 1? Oh, sorry, 2, 1. And numbers bigger than 5 are 6, 7, and 8. So if we're looking at numbers that are on the left side here, that's the less than 5. That's my left-hand side. So what does the graph look like on the left-hand side? Well, just plug in 5. And this problem is confusing when you don't know how to read the problem. So at 5, let's plug in 5, and plug in 5. 6 minus 5 minus 5 squared is 1 minus 25 is negative 24. The graph looks like negative 24 from the left side. Well, how is that different than the next question, which is now the right side? You see a plus sign here? That's the right side. Now, what happens instead of using the same equation, we use the second equation because that only exists on the right side. Let's go ahead and plug in the 5. Be 5 times, sorry, let me rewrite that. 2 times 5 minus 34 is 10 minus 34 is negative 24. Negative 24 also. Now, if we said the left side is 24 and the right side is 24, what does it look like? You say Mr. Ko is tall, someone else says Mr. Ko is tall. Guess what? Mr. Ko is tall. If they both agree, the limit is going to be 24. It's going to be the same value. Ooh, still too good. All right, so let's look at number 8. 8 is very, very similar, except now we went back from, instead of looking at the piecewise function, we're looking at the graph again. Okay. Now, just something I want to say here, looking at this problem, does the limit exist at negative 2? So looking at negative 2, the right side says 2, the left side says negative 1. So do they agree? Do they agree? When you don't write a plus or minus, it means you have to agree from both sides. And they don't. So the answer does not exist. Okay. Let's keep on going. We got to get through this review. Now the next part is limits. And these are easy limits. Whenever you have a limit, the first thing you should try to do is just plug it in. And that's what we should do. Plug it in and see what happens. So these 3 questions here, we're going to go ahead and plug it in and see what happens. Plug it in. 8 times 8 minus 1. What's 8 times 8 is 64, minus 1 is 63. Yes, the problem looks like 63. No doubt. We have no doubt about that. Plug in 1, plug in 1, plug in 1. 4 times 1 squared minus 2 times 1. That's 4 minus 2 is 2. No doubt, this is 2. The first graph was a simple line. There are no weird things that are going to happen with a line. The second graph is z squared. That's a parabola. Nothing weird happens in a parabola. But the third problem here, the third problem is a fraction, and things can happen that are weird in a fraction. And if you look here, if I plug in the 4, let's go and plug in 4. That's going to be 4 squared is 16 minus 28 plus 12 over 4 minus 4. This gives us negative 12 plus 12 over 4 minus 4 is 0, 4 minus 4. That's 0 over 0. And now we realize something weird happened here. When we have fractions, we cannot divide by what number? We can't divide by 0. And this is a special occasion when we have something called an indeterminate. Indeterminate, okay? Indeterminate form means something says 0 over 0. That means we can't determine it, hello? And that means there's a hole for us. So instead, we're gonna factor it, x, and I'm guessing there's gonna be a 4 here because it has to cancel the 4 on the bottom. But two numbers to multiply to become 12 is 3 and 4, and do they add up to become 7? 3 plus 4 is 12. 3 times 4 is 12. 3 plus 4 is 7. Yep. We have 3 and 4 and both being negative. And please take a look here. We do have a common factor. Common factor. When these divide out, we are left with x minus 3. Now, I made a mistake here. You need to write the limit. We're going to write limit until we plug it in. And the common factor is x minus 3. Now, in this case, we can now plug in number 4. 4 minus 3 is equal to 1. And that's the limit. That's what it should look like at the hole. I get it, the value does not actually exist at 4 because we would have divided by 0, but that's what it should have looked like. And when you graph this, this is where the hole would be. And that's us dealing with problems like that when we have a hole. Number 12, very similar to that, except when you factor, you're going to realize it's to go. When we plug in negative 7, in this case, we're still going to end up with 0, 0. Factor it, and you'll see that a common factor divides out. Now, number 13 and number 13 here, we're going to, again, finding the limit. Now, I'm going to go ahead and plug in 0 here and see what happens. So, we're plugging 0 over 0. We end up with negative 1 squared minus 1 over 0, which is 1 minus 1 over 0, which is 0 over 0. Oh no, 0 over 0. But actually we should actually turn this frown upside down and say, hey, if it's 0 over 0, I could probably do something with this. And in this problem here, I can't factor. Maybe I could multiply out. And if I multiply this out, it'll be negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2h plus h squared minus 1 over h. If you look at this problem, we see that negative 1 cancel out. We end up with limit h gets closer to 0 of negative 2h plus h squared. And we talked about this before, that I can divide these h's out. And we're left with the limit as h gets closer to 0 of negative 2 plus h. And we can go ahead and plug in one more step. Let's go ahead and plug in 0. Our answer is negative 2. The answer is negative 2. And that is our limit. Now, this is also our f of x plus h minus f of x over h problem. So this was just a setup for you guys to practice what we're going to do next. Now, question number 14 and 15 and 16, these are all the problems that you guys are going to have to find the limits for. So I'm going to make sure you guys can do this by doing this right now, demonstrating them. You guys are going to be asked, use the limit definition of the derivative to find the slope of the tangent line to the curve. And that's my first curve. So we're going to do f the limit as h gets closer to 0 of f of x plus h minus f of x all over h. Now see, this is a fancy way of saying slope. These are 2 points, and the 2 points are so far away from it, there are 0 spaces apart. Oh my gosh, 0 spaces apart. That means you're right next to me. Awkward. But that's the idea. What would it look like? Well, we tried to demonstrate this yesterday to show you guys visually that you want the 2 points of slope to be the same point to try to get the most accurate tangent line possible. So we're going to actually do that. The limit as h gets closer to 0 of 2x plus h squared minus 2x squared all over h. Now, please be advised, remember, this is actually 2x squared. So the new version is 2x squared, but x is replaced with x plus h. That's the only difference between the new version and old version. Every time you see an x, you're going to plug in x plus h. We're going to actually do that with the problem down here. The limit as h gets closer to 0 of f of x plus h minus f of x all over h. We then have to say the limit. This one's going to be a long one. Approaches 0 of 7 squared minus 2 plus 2 minus 7x squared plus 2x plus 2. This one is going to be a longer one. And we write inside each of these x's as x plus h, x plus h. Okay, so pretty much we are mimicking what we're doing up here, except sure, the problem is a little bit bigger. But every time in the new version, the front version, we always write x plus h whenever I see an x. Do not be afraid of doing that. So let's go ahead and do the top. The limit as h gets closer to 0 of 2. I'm going to write x squared plus 2xh plus h squared. That is the square of x plus h minus 2x squared over h. Let's continue with this. This is going to be the limit as h gets closer to 0 of 2x squared plus 4xh plus 2h squared minus 2x squared all over h. I'm going to go ahead and get rid of 2x squares. We're left with the limit as h gets closer to 0 of 4xh plus 2h squared over h. Now you guys have to practice that yourself to be really good at it. I'm going to divide out the h's, h. See you later. And we're left with the limit as h gets closer to 0 of 4x plus 2h. We can plug in 0, and my answer is 4x. Now, that is a slope, as we showed yesterday, for the whole graph. Every problem you want to plug in, we can find the slope. This is an automatic answer for you. Now, which answer do they want? They want x at 2. So just plug in 2. 4 times 2 is 8. And that is the slope when x is 2 of 2x squared. The second problem down here is going to be a lot longer. So I'm going to go ahead and multiply that out, and multiply this out. I'm going to get rid of all those numbers. So it's going to be 7. So as h gets closer to 0, 7 times x squared plus 2xh plus h squared plus 2 times, well, that's a positive 2. Oops, I'm glad I saw it now. That's positive 2. Plus 2 times x is 2x plus 2h plus 2 minus 7x squared minus 2x minus 2 all over h. These problems are a lot of writing, that's fine. This is going to become 7x, limit, h gets closer to 0, 7x squared plus 14xh plus h, 7h squared plus 2x plus 2, 2h plus 2 minus 7x squared minus 2x minus 2 all over h. Oh my goodness, so much writing. But these problems are just, that's what it is. I see a lot of like terms I can cancel out. And then here, I'm going to do this since we're kind of on it already. I'm going to say, hey, if I divide h here, all these get divided by h, right? So we're left with the limit. H gets closer to 0 of 14x plus 7h plus 2. Now you can see that h is going to be 0. We only have plug in h at the end. We're left with 14x plus 2. What's the x? X is 1. Replace that with a 1. 14 times 1 is 14. 14 plus 2 is 16. And number 16 is our easiest one. I saved that one for last. The limit as h gets closer to 0 of 4 times x plus h minus 6 minus 4x minus 6 all over h. Now, I can do this so quickly because I've done this so many times. You can do this so quickly, just do it 3 times. if you can do each of these problems 3 times, you can see the pattern. And the pattern is actually very simple. The limit as h gets closer to 0 of 4x plus 4h minus 6 minus 4x plus 6. Now, all this math is really just algebra 2. We have like terms 4x and 4x and 6 and 6, and we're left with h's. Look, h's divide out, and the only number left is 4. The limit as h gets closer to 0 of 4, A's answer is 4. Okay, that's it. That's your review for your test number 4.